Question number 3 here is basically on Tutor Profile. So question number 3 here, it says that in triangle XYZ over here, XZ equals to 7 cm, AY equals to 18.9 cm, and YZ equals to 25 cm, and angle XAZ equals to 54 degrees. We can see that XAY forms a straight line. So find the length of AX. So pretty much for the length of AX, you can see that, oh, we have an angle 54 degrees over here, and we have another length of the side of the triangle. And this is a right angle triangle. So that tells you that you can use Tutor Profile. So what we're going to do over here is we're going to look at this angle over here. So then this will be the opposite, and then this will be the adjacent, and then the side that is directly opposite the right angle will be the hypotenuse. So we want to find the length of AX, which is the adjacent, and then we have our O. So remember Tutor Profile, TOA. So we have our O and we need to find our A. So then we use tangent of the 54 degrees equals to O over A, which in this case O is 7, and A is the one that we want to find, which in this case is AX. So tangent 54 degrees equals to 7 over AX, in which if I were to key this into the calculator, okay, let me rewrite this. So this AX equals to 7 over tangent 54 degrees. Now let's write this with the intermediate step. So this gives us, after keying your calculator, we get 5.0857, which is rounded off to 5.09 cm. So rounded off to 3 significant figures, and we are done with 3A. So let's move on to 3B. So sine angle XYZ. So sine angle XYZ over here. So based on this angle, right, the opposite is here, the adjacent is here, and then the hypotenuse is here. So we have our O and our H. Okay, so sine angle XYZ is actually so. It will be opposite over hypotenuse. In this case, it's actually 7 over 25, and we are done with 3B. Rather straightforward. So 3C, we are supposed to find angle XYZ. Sorry, XZY. So we are supposed to find this angle over here. So based on this angle over here, right, we can see that, sorry, that's not the angle. So angle XZY is this angle over here. So based on this angle over here, then this will be my adjacent, this will be my opposite, and then this will be my hypotenuse. So in that case, since I have my adjacent and my hypotenuse, I will use cosine. So cosine angle XZY equals to A over H, which is equals to 7 over 25. So then angle XZY will be equals to the cosine inverse of 7 over 25, in which if you key this in your calculator, you will get the angle 73.739 degrees rounded off to, for angles, 1 decimal place, 73.7 degrees, 1 decimal place. So this will be angle XZY. Okay? So that's it for 3C. Now finally, we are supposed to do 3D over here, which not too hard. You just need to understand the method. We want to find the shortest distance from X to YZ. So this is what the question wants you to do. We want to find the shortest distance from X to YZ. So this will only happen, okay, when this line is perpendicular to YZ. Okay? So this will be my shortest distance. So what we can do over here is to use the area of the triangle. So earlier we have found that the length of AX is actually 5.0857. So what we're going to do is we're going to find the area of the triangle XYZ, which is equals to half times base. In this case, let's say this is the base. 5.0857 plus 18.9 times the height. Okay? So in this case, the area XYZ will actually be equals to, after you key in your calculator, you get 83.95 cm squared. So there's also another way to find the area of xyz. So we can actually take this as the base, right? And then we take this as the height. So let's call this the height, which in this case, this height will be the shortest distance from x to yz. And this line that I have drawn over here, this dotted line, is actually perpendicular to yz. In such a situation, or in such a scenario, yes, then this line, when it is perpendicular from x to yz, this line will definitely be the shortest distance from x to yz. So what we're going to do is we're going to find area xyz in another way, which is equals to half times the base 25 times the height h, which is the shortest distance from x to yz. And this line here, the dotted line, is actually perpendicular to yz. So we're going to equate this with this. Okay, so half times 25 times h equals to 83.949. So in which this is 12.5h equals to 83.949. Solving for h, we divide the 12.5 over. We get that the height is actually equals to 6.71592, rounded off to 3 significant figures as usual. So 6.72 cm, 3SF. So this will be the shortest distance from x to yz. And we are done solving 3D using the area of a right angle triangle and finding it using two ways and then equating them. And then we solve for the shortest distance from x to yz subsequently.